6, chapter 18, theory video 8, the orbital period. So you know what period means. Period means one complete unit, right? Period is how much time it takes to maybe if it is to go around a circle, then it is one to go in one orbit. So that is a period. It is more often useful to consider the time taken for a complete orbit, the orbital period t. Since the distance around an orbit is equal to the circumference 2 pi r, it follows that velocity is equal to displacement divided by time taken. So in this particular situation, distance is 2 pi r, orbital speed is equal to 2 pi r divided by t, right? So now we have another equation for v squared. V squared is equal to gm upon r. So then what we do is we square 2 pi r and t. If you square 2 pi r and t, you will get this equation, right? So you square them, then you get 4 pi squared r squared divided by t squared is equal to gm upon r. Then you have an equation for t. T squared is equal to 4 pi squared divided by gm into r cube, right? So then if you want to find t, you have to take the square root. This equation shows that the orbital period t is related to the radius r of the orbit. The square of the period is directly proportional to the cube of the radius, right? So as you can see here, this is an equation and there is no r is not a denominator. So as a result, t squared is directly proportional to the r cube, right? This is an important result. It was first discovered by Johannes Kepler, who analyzed the available data for the planets of the solar system. It was an empirical law, one based solely on experiment, since he had no theory to explain why there should be this relationship between T and R. It was not until Isaac Newton formulated his law of gravitation that it was possible to explain this fact. So Johannes Kepler is not only important in the aspect of discovering planets, but he was also one of the pioneers in establishing that gravitation existed. Right? Everyone knew that gravitation existed, but explanation is a bit of a difficult theory. For example, there are a lot of relationships that exist in the universe, and some historical facts are quite important for us to know, and we might not know them. They just skip our mind. For example, you may have heard about Robert Knox. Robert Knox is one of the pioneers of people. He was actually related. He's related to Sri Lanka in many ways. And when Robert Knox visited when he visited Sri Lanka, he discovered the plant cannabis, and he returned to United Kingdom, and his friend Robert Hooke, who is a pioneer in biological experiments. You have learned about Robert Hooke in biology. Robert Hooke was introduced to this plant by Robert Knox. So in a way, Sri Lanka has actually introduced cannabis to the United Kingdom. So my point is, the Johannes Kepler having the initial steps in discovering this gravitation without knowing how to prove that it exists using the mathematical formulas actually provided the basis for Newton to work on his theories. So um, you can discover new things, right? You might not be able to prove those things, but that doesn't mean, just because you cannot understand something, that doesn't mean that you can give the credit to some unknown deity, any god or anybody. But there is an explanation, someone else in the future. You can be the Johannes Kepler, and there would be a Newton who would prove your point with a mathematical formula. So the point is, there are things that that happens all around us, things that we cannot see, things that we cannot understand. It is not just because we don't understand, just because we cannot see that, that does not mean that it is done by a god. There is a reason behind that. There is physics behind that. It is just up to you to prove it. So empirical laws, you can divide, you can do experimentation and prove your point, and someone will bring out the theory in the future. Um, uh, Going forward with the lesson, orbiting the Earth has a natural satellite, the Moon, and thousands of artificial satellites, man-made satellites, and some spacecraft and a lot of debris. Uh, Spacecraft in the sense, International Space Station, where a lot of people are there right now. That is also a part of this, and you must have heard that the first movie was shot in the International Space Station just a few days ago, and the first Russian actress and her crew returned to the Earth. I think it was just yesterday. Um, they have been in orbit for more than 12 days, and uh, uh, when they go in orbit, they all use the Earth's gravitational field to provide the centripetal force necessary to keep them in orbit, right? So if a satellite has to maintain that orbit, it has to have that speed, right? So if that speed is not maintained, then it will crash onto the ground. So that means if it exceeds, then of course it will escape the gravitation, but if it reduces, then it is going to slowly crash onto Earth. So the equation is v squared equals gm upon r. It follows from this equation that the closer the satellite is to the Earth, the faster it must travel. If it travels too slowly, it will fall down towards the Earth's surface. If it travels too quickly, it will move out into the high orbit. And finally, it will escape if it continues to increase its speed. Please write down a note. Orbital period. The time taken for a complete orbit is known as orbital period, within brackets capital T, and it can be obtained as follows. Leave a line and write circumference of one orbit equals 2 pi r. Next line, time for one orbit, capital T, then v equals, that is orbital speed, equals 2 pi r upon t. V equals 2 pi r upon t. Substituting v squared for this equation, then write this equation, please. 4 pi squared r squared divided by t squared equals gm upon r. And then rearranging this gives us t squared equals 4 pi squared upon gm into r cubed. Leave a line and write. This suggests that t is related to the radius r in such a way that square of the period t is proportional to, is directly proportional to the cube of the radius r cube. For an object to go in orbit around the Earth, it has to maintain the orbital speed given by the equation. Put a comma and write down in next line, v square equals gm upon r. If the satellite travels too slowly, it will fall towards the Earth. Or if it goes too fast, it will go into higher orbitals and a continuous rise in speed will get it thrown out of the Earth's gravitation. I hope you understood. Please answer question number 12.